Hello there. Welcome to the Async API Online Conference. This is pretty cool. My name is Ken Lane. I'm going to talk to you today about a Slack API index, which is a mix of OpenAPI, Async API, Postman collections, and Alps, all indexed using APIs.json, which we'll walk through each of these specifications here shortly and show how they all can work in concert. This whole presentation is meant to be an interactive presentation that anyone can experience. So the URL is here. I'll make sure it gets published as part of the show notes so that you can come here and walk through this as well. Let's get going. So first of all, I'm the chief evangelist at Postman. If you're not familiar with Postman, it's a HTTP client that in the last couple of years has matured and evolved to become a full-blown API platform. We have 10 million developers, and you can use Postman to make API calls, save them as collections, build tests, documentation, mock servers, and a whole bunch of other things. But I joined Postman about 6 months ago, and I'm the chief evangelist helping enterprise organizations think about the API lifecycle and get more organized and strategic about how they do what they do. Some of you might also know me as the API evangelist at APIevangelist.com, where I've covered the technology, business, and politics of APIs for the last 10 years. I started the blog back in 2010, and about 6 months ago, I joined Postman, and while I keep working on the blog, I'm just continuing my work on the API lifecycle and working with enterprise organizations and talking to Postman customers. So to show how all of these specifications work together, let's start with the OpenAPI, which really is the most ubiquitous and oldest of the specifications I'm going to talk about today. Slack maintains their own OpenAPI specification. You can find it on GitHub. And I've taken a subset of this API definition for this presentation. It's actually, the full Slack API is pretty big. So I had to trim it down to just some around conversations using Slack. So let's walk through OpenAPI before we get to the other specifications to kind of connect the dots here and see what they're all about. So OpenAPI begins with an information block that gives us the title and description of the API. We're profiling the Slack web API here. So this is the HTTP API that you can use to interact with the platform. The info block has contact information and whatever version we're at with Slack. That gives us a server block that gives us details about where we can find the base endpoints for the API, as well as Slack gives us auth endpoints. I've seen other providers provide mock, staging, and other sandbox or regional-based APIs as part of the server definition. While the OpenAPI gives us details about the path, each of the individual paths that are available for an API, including the HTTP method, whether it's a get, post, put, delete, or other type of HTTP verb. Each HTTP method gives us a summary as well as a full description of what that API can do, providing us with as much details about what you can do with that individual HTTP method when integrating with the Slack API. Also gives us details on parameters. You can describe header, path, or query parameters using this object. So you can describe the name, what type it is, where it's in the header, the path, or in the query. You can provide a description as well as schema and other details about each individual parameter. You can also describe the request body and details about if it's a post or a put, that you can pass, what type of information you can pass in. In this case, it's a a form and you can submit channel information. And so this gives us the details of the request body and what's expected when it's being submitted. You can also find the responses. Hopefully there's more than one, but there should at least be a 200 status that gives us the details of what we can expect when we make a successful API request, giving us the details of the response, including a reference to the schema, which you can see we can expect back an application JSON schema, and it gives us the reference to where we can find it. This reference provides us with a reference within this document that helps us see the entire object that we can expect to get back, giving us details of what's required, the properties, and other schema data types, examples, and things that go with those properties, helping us understand what's expected back as part of each response and what should be included as part of each request when we're working with each of these individual API paths. So OpenAPI is formerly known as Swagger, is pretty widely known to be for documentation. That's its number one use. So why you want to create an OpenAPI definition. It provides all the common details you would need to document the API for your consumers. But it's used much more for that. Beyond that, you can use it to generate mock servers, use it for testing, many other things that you can accomplish with it. But it really helps to have a up-to-date, robust, complete enough OpenAPI definition that you can use for whichever stop along the API lifecycle suits what you're trying to accomplish. So after OpenAPI, AsyncAPI is the next most widely used, fastest growing, widest tool base API specification out there. So OpenAPI started in around 2010, 2011, and became, about the time it was becoming OpenAPI, AsyncAPI emerged to kind of augment and act as a sister specification for OpenAPI and help us make sense of the beyond HTTP with pub/sub, event-driven, and message-oriented APIs, giving us a new specification that we could use to describe the APIs that we're building. So like OpenAPI, it uses a similar pattern and provides us with an information block, giving us a title and description of the API, contact information, terms of service, and what version we're dealing with. So you also get a servers block, but you get a little bit more detail here with AsyncAPI. You get the description and the URL. You get some variables that can be passed in, but more importantly, you get a protocol property that allows you to define if this is HTTPS, if you're going to switch to WebSockets, if you're going to be using TCP, MQTT, or other. It allows us to define the servers that are behind each of these APIs, going beyond what OpenAPI can do with HTTP alone. It helps us define, AsyncAPI helps us define our channels that users can subscribe to or publish to. And Slack provides us, similar to the paths we have for our OpenAPI and our request and response, Slack gives us a variety of channels that we can subscribe to when it comes to staying in tune with activity on Slack. Each of these channels is given a basic summary, helping us understand what actually each API does. Allows us to tag and organize our APIs, and then describe our payload by providing references to the schemas that a consumer can expect to get back when they subscribe to one of these channels. Similar to OpenAPI, it uses references as well as JSON schema to define these payloads. So the Slack API does not share a common schema between its request and response and its event-driven API, but you can, because it's both JSON schema, you can share schema across your HTTP and your TCP and other APIs. So it allows you to define your schema using JSON schema, have those either stored individually as files as well as within your Async API or your OpenAPI, and referenced and used as part of the request response payload for these APIs. Gives you a much better control over the JSON schema and how you're using it. So it gives us the full details of what can be expected as part of each payload, just helping us get more organized about how we manage our schema. So just like OpenAPI, Async API can be used to generate documentation. It's definitely one of the biggest benefits is to have it make the API more tangible, more useful, and keeps your documentation up to date and consumers in sync with what's happening and what's needed to get going. But like OpenAPI, you can use that Async API specification for many other stops along the API lifecycle. You can generate your docs, your mocks, you can generate tests, and do many other things with it that you will encounter as you're trying to develop and support your API. So next up, after OpenAPI and then Async API, let's take a look at Postman collections. So Postman collections are an open source format from Postman that, similar to OpenAPI, allows you to describe the surface area of your API requests. You can generate Postman from OpenAPI. You can import your OpenAPIs using the Postman client and generate and output Postman collections. Postman collections provide you with an information block similar, allows you to give it your collection a name and a description, helping understand what this specific collection is for, what it does beyond the OpenAPI definition. Like the OpenAPI, it provides details of the request. It has your auth, your HTTP method, the headers, your body description. So it has a lot of the same elements that are present in your OpenAPI definition. But if you look, we actually have values for our headers in this one, and we can actually provide the details of our body and actually make specific API requests to our API. So we can build collections that actually carefully craft specific requests we want to make, or a series of requests we want to make in a specific order with certain information. So we can actually interact with Slack and actually make one or many API calls with specific values using the API, using these Postman collections. So once we have a collection defined, either making a single request or a series of requests, we can use those within Postman to actually run them as monitors, scheduling them using different cloud infrastructure, setting them to run at different intervals, and scheduling and automating the execution of these specific collections that have a specific business purpose. We can run them as runners manually, and then we can export them and use them in CI/CD pipelines using Postman's open source Newman runner. So the collection itself, as well as the runner, are both open source, and you can execute those within your infrastructure, or you can use the Postman platform to actually scale those and execute on them. Next up after Postman is Alps. Alps is a format and specification for defining the semantics and actions that exist across an API platform. So I've auto-generated this Alps document from the OpenAPI. So what it's done is it's gone through and taken all of the properties from all my schema objects and organized them so that I have a list of all the properties that can be applied across API operations, or this specific set of APIs. Then using grouping, I can group these. So I'm grouping them similar to how I have my objects defined in my JSON schema. But Alps gives me a much looser way of defining the properties and the semantics of how I'm using my APIs, allowing me to, yeah, this is a specific object. It's a history success object, but it allows me to more loosely organize it in the way of a specific action that's going to be taken. I'm adding something, I'm updating the basics, but the semantics of that are probably greater. So Alps allows me to define that in a way that is a lot more flexible. And then I can associate that with specific actions that are either safe, idempotent, or unsafe, depending on whether it's a get, a post, a put, or a delete. But this really starts defining, allowing me to get beyond just my CRUD and kind of my caveman vocabulary of my OpenAPI and actually look at the actions that can be taken across. This particular one is generated from the OpenAPI. I'll be doing the same from the Async API, creating one single Alps. Maybe I'll create two separate Alps documents, one for each. But it'd be nice to have vocabulary across both the request and response as well as the event-driven API. So all of this allows me to visualize and document and better understand the activity that occurs across API platforms. So Alps for me is very much the what's possible. Here's the actions that can be taken. I can then marry that with an HTML kind of my web strategy, and actually develop forms, buttons, and other action enabling embeddables that I can use across my applications and use across the web. And then, this helps me really start defining not just actions that can be taken, but the events that occur as a result of those actions. And so this gets into the event-driven side that Async API brings to the table. So I'm hoping that Alps is going to be be that bridge. If you think of it, schema.org is the different objects, the common objects, and the vocabulary for those objects. I see Alps as being that similar common vocabulary, but for the actions, the verbs, rather than the nouns. So this really helps me understand the real-time event-driven nature of the landscape using an artifact that helps me see that. So lastly, the final document or artifact that we'll have in here is called APIs.json. APIs.json is a specification that I developed with my partner in crime, Steve Wilmot from 3Scale, but now Red Hat. And it came out of work that I did for during the Obama administration for a data.json file for federal government data. So you could find data.json files in the roots of top-level cabinet agencies' websites, and it provided a machine-readable inventory of their public data assets. So after leaving DC, I needed the same for APIs. I needed a sitemap.xml for APIs, and we created APIs.json. It's still in its early versions, and we're going to do some more work on it. But this one here is an index for Slack, providing us an index of Slack API operations. So similar to the other artifacts, we've got a name and description of this collection. Rather than the API itself, whether it be in the web API or the event, this is the API operations. This is Slack. This is what Slack does, and its image, logo, and then it has tags and when this index was created and when it's been modified last. So this base core set of info describes this collection of APIs, this platform or operations. And then it gives us an APIs object array that we can put many different APIs in here. For the Slack, we've got two. We've got the web API as well as the events API. For the web API, we have a description, an image, and a set of tags that describe it. But more importantly, we have set of properties, and these properties have a type and a URL. And in this case, it's an OpenAPI spec. So it's the OpenAPI spec that we just looked at the beginning of this talk. It's a reference to that OpenAPI saying, hey, for the web API, here's the OpenAPI definition that you can process. We also have a Postman collection property that gives you the URL for the Postman collection, allowing you to pull that in and put that to use. We could have multiple Postman collections accomplishing different business objectives, and they can each be indexed here as part of the Slack API. And then we've got our Alps definition. So this gives us the vocabulary for the web, the actions that could be taken as part of the web API, providing us with three pretty key indexes of machine readable artifacts for the Slack web API, allowing you to pull it as part of this APIs.json, but then pull those formats using these properties. If we jump down to the web API or the Slack events API, excuse me, we have an individual JSON schema. They provide the common event wrapper schema for their events API on GitHub. And so we have an actual JSON schema file all by itself indexed here for use outside of the Async API that's also included here. So we have a full description or reference to the Async API for the Slack events API, providing the details of this API alongside the details of the web API above. We also have a set of common properties. So these span across both all the APIs being offered as part of this Slack API collection. It gives us URL types and URLs to some common human readable references as part of the Slack API operation. So the ones above were machine readable artifacts. These ones ideally would be machine readable artifacts, but they just haven't matured along. Actually, a couple of them are. Look, if you look at the blog RSS, that's a machine readable artifact. And if you think about it, references to Twitter or GitHub, because they have APIs, technically are also machine readable artifacts if you have proper authentication. The goal here is to provide the common building blocks of the Slack API operations that you might want to put to use as a consumer. And so this is all indexed as part of a common set of properties that can be used. And then lastly, the APIs.json describes who's the maintainer in this situation. So this particular, this particular APIs.json collection is maintained by me. Slack didn't create it. So I'm actually curating it and managing it. And so I'm listed here as the maintainer, and it's got some basic contact information for me. So this APIs.json can be used to drive, reference cards, website listings, anything, pulling that APIs.json, plugging it into your React or other single page app, and then you've got an index for an API. So here's a card that lists the name, the logo, the description, as well as some basic getting started, details that most people are going to want with an API. You can pull the common properties and show legal and support and other information that developers are going to want to get at. You can show these as icons. There's just many ways to pull the APIs.json information and then display it. You can make external resources available, show the GitHub, Twitter, Facebook, YouTube, the bulleted list as a set of icons, provide access to the status and transparency board that Slack provides, and then their security overview page. So this really starts indexing and making available really important links on as part of the Slack API operations. But this can be embedded on any site and any documentation used across social media, and then quickly make the API more accessible, as well as extending the reach and the network of that API using APIs.json. And so hopefully all of this kind of shows how multiple API specifications can work together to help us map out the landscape across our API operations, as well as map out the landscape that exists on the open web. So I use these to describe APIs that I find across the web. I use it for Slack. That's why I have this one. That's why I created it. Uh, you can see OpenAPI strength is allowing me to describe the surface area of the HTTP APIs that I'm profiling. It gives us all the details in this case of the Slack web API. Async API allows us to go further and describe pub sub message and allows us to get beyond the HTTP protocol and look at TCP, MQTT, and start describing in a consistent way, in a way that's consistent with OpenAPI, describe the surface area of those APIs. So between OpenAPI and Async, we've got pretty good coverage. But then Postman comes in and allows us to execute on specific actions, specific requests that need to happen across the HTTP API. And so we can craft individual Postman collections that help us realize specific business scenarios, specific workflows that we need to test or document, and define those as individual collections, and then run and execute those as part of a schedule or as part of a pipeline, and accomplish specific things around our request and response APIs. And then, of course, JSON schema is used across OpenAPI and Async API. Postman uses it to validate Postman collections, and that JSON schemas allows us to just define the underlying schema for our API infrastructure. And then Alps is hopefully going to allow us to really define, well, what is that action vocabulary that we have available to us. We have all of these nouns described, and how do we describe what the potential is? What are the actions that can be taken? Not just the CRUD, the create, read, update, and delete, but what are the actual meaningful actions that can be taken across both these APIs, and what can we subscribe to? And then the flip side of that is really, what are the events, the outcomes of those actions that can be taken? And that's really the event-driven side that Async API lets us describe. So my hopes is that Alps is going to help us be this bridge in rapidly mapping what the actions that can be taken, what are the verbs that exist across our request and response structure, as well as our pub sub and event driven. But then how do those translate into meaningful events that we can tune into the signals from? And so JSON schema and Alps really helps us just get a handle on our vocabulary and what's going on. And then APIs.json wraps all of this and provides us with an index of all this machine readable goodness, as well as the other human aspects of API operations that aren't machine readable yet, but are going to have to be if we're going to do all of this. So my goal in doing this presentation, this talk, is to really show folks that there's not one spec to rule them all. It's good that there's multiple specs out there. I know there's a lot of talk of Async API replacing OpenAPI, or what's more realistic, what's the future. And having, I don't even have RAML, I don't have API Blueprint and other viable API specs listed here. And my point is these specs should be able to live in harmony. They should be able to work together. They have strengths and weaknesses. There are some overlap between them, but they have distinct purposes. And if we're aware of them and we use them well for those purposes, and we have them indexed properly, that we can get more organized about this. I'm seeing other specs emerge, like one for monitoring and service level agreements coming out of Spain. And so I'm seeing other ones emerge like that are help out with specific stops along the life cycle. I'm seeing specs for just security. You can look at what 42 Crunch is doing, and their security artifacts are pretty compelling in what they've done with the OpenAPI. But both of those should, in my opinion, not live just within OpenAPI and bloat that spec. They should live outside of it. They should either be a sister spec or an overlay and augment what's going on and be able to stand on its own, similar to JSON schema as its own individual artifact. So hopefully that whets your appetite as far as what's possible when it comes to API specifications. I'm really excited still about OpenAPI after all working on it all these years. Really excited for the opportunities with Async API and then now being part of Postman. And we're going to do some more work on APIs.json and hopefully bring it up to a version 1, something that's a little more stable and usable that people can put to work. Anyways, I'll take questions, and I'm happy to talk to anybody about these specs. And you can reach me anytime. Just look for Ken Lane API Evangelist. I'm pretty easy to find. All right. Well, thanks, everyone.